Hello and welcome to this PV TechTalk Product Series webinar co-hosted with LONGi Solar. The title of today's webinar is LONGi's Hi-MON N-type TOPCon breakthroughs boosting efficiency and energy yield for large-scale PV. My name is Liam Stoker and I'll be your moderator for today's webinar. Joining me today is Vitor Rodriguez, who is Technical Services Director for Europe at LONGi Solar. Now, before we start, some quick housekeeping. Today's webinar will last approximately 30 minutes, consisting of a presentation and Q&A session where you'll get to quiz Vitor and LONGi on all things N-type. You can submit your questions via the dialog box on your screen, and we'll endeavour to get through as many questions as possible today. If we are unable to get around to your question, if you could provide your email address, and we'll liaise with you directly. The slides and a recording of today's webinar will also be available shortly after the presentation. But without any further ado, I'll hand over to Vitor to begin our presentation today.
Hello, Liam. Thank you so much. So first of all, allow me just to thank PV Tech for this opportunity for LONGi to present the newest technology that we are launching this year. So Liam and the team, thank you so much for the opportunity. As Liam mentioned, I'm Vitor Rodriguez, Technical Director for Europe at LONGi Solar. And today's topic is to present you our newest Type N TOPCon technology solution that we are launching this year. So we mentioned here that we are still advancing on cell technology. Just refer that as we know, LONGi is not only a module manufacturer. In fact, we started as wafer manufacturer. So we have the entire chain from the polysilicon to the final module. And we say still advancing cell technology because LONGi has been one of the leaders in cell technology evolution. And today the topic is very related to the type of cell that we are now using to produce our modules. So this is the solution, is Type N. Coming from the basics, let's say that the Type N and Type P, on a very simple way, depending on the way you treat the cell, you can get the cell positive charged, and this is the P-type, or negative charge, and this will be the N-type. In fact, the N-type is now being more penetrated to the market, to the sector, but in fact, the N-type is known for many years. The reason why P-type was in the beginning the most used technology has to do with the fact that in the beginnings, the PV cells were most used in outer space solutions, applications, and in that case, it was found that the P-type resists more to the outer space conditions. But we know, the sector knows, the N-type for many years, and even if it has extra costs on the treatment, now that we are searching for more efficiency, that we had a discussion about getting more power, but by growing the size of the modules or not. And at LONGi, we are very fond of the efficiency. So what we are searching for is not just growing output power by growing the module, but mainly by increasing efficiency. So the Type N TOPCon is the solution that today we are presenting to answer this need of growing in the efficiency of our modules and, of course, increasing our turnover and of our investment. So basically what we have here is the new cell that is negatively charged, that has the treatments, and with this we increase the efficiency. And to give you some numbers, at LONGi we always use external entities, well-known, like reference entities like Fraunhofer, ESFH, and so on, to also help us in the studies of our solutions. And I present you here a lab record that was given to us by Fraunhofer in our cell, so we are speaking on the cell level, but also very important when we look not to samples for laboratory testing, but when we think on mass production and commercial manufacturing, we achieved internally 25.1% efficiency on our newest cell. So this is still on the cell level, and to give you just a little bit more clarification on the the layers and the cell, the N-type cell, is made, and also to introduce the concept of high performance cell. This is something that when we look to the roadmap of the PV sector, we came from increasing efficiency with other technologies, and we were saying that around 21, 22, we would be using high performance cells. So this is a reality, and the Type N TOPCon is an HPC cell technology. Now moving to the module itself, I also had the pleasure last year with PV Tech to present us our model that we launched last year, where we had the increase of the wafer size. We came from M6, 166 millimeters, to 182 millimeters. And then we all the sector had a discussion about the 210 millimeters, 182 millimeters. And if we recall this discussion, LONGi always had the point that we consider that 72 cells, so 144 half cells, M10, 182 millimeters, would be the optimal size for the module. And this, just to say that the design of our module using the N-type cells is exactly the same as we use for our other mainstream product that we call Hi-MON 5 series. So we know we have now 1 year of experience in projects with this design, with the 9 bus bars, with the number of cells, with the dimensions, and we are keeping the same design. And I will try to explain a little bit better later why we consider that this is the optimal solution regarding the dimension of the modules. We also introduced with the Hi-MON 5 the topic of the smart soldering, where we change the shape of the soldering from circular to segmented, because in fact it has two shapes, the triangular and the flat one. Triangular when you solder on the top of the cell, and flat when you solder on the rear part of the cell. These allow us to achieve some interesting results, like increasing the efficiency. Also, and most important, to reduce the tensile tension that we need on the time to perform the soldering, what means reducing the costs of energy, also reduce product defects, because the soldering process is one of the processes that all manufacturers have more potential to have defects on the cell level. And this, it was a very interesting optimization of the soldering process. But besides all these advantages with the smart soldering, we also conducted tests on one of the most important topics if we look to the growing of the size of the modules. And I'm referring to the resistance to mechanical loads. So to wind loads, snow loads, and so on. What we did was to compare the type of soldering with the circular or normal ribbon with the segmented one, and we conducted static mechanical load at 5,400 Pascal and dynamic mechanical load at 1,000 Pascal, and try to understand what was the results on the cell level. And you can see by the picture I'm showing to you that the reduction of defects or cells with cracks, because we are showing electroluminescence pictures, was quite interesting. And this is also very interesting when we think about the mechanical load we need to give on the model level to our final client. On a very summarized way, when we design a module and we try to bring other solutions to the sector, the efficiency that I mentioned, more than exactly the output power, but the efficiency is one of our main targets, but not only. We try during the design to look to the compatibility with the rest of the components that are part of a PV plant, like, for example, the string inverters, the trackers, the fixed structures. Also to understand how the module will behave in certain conditions, like, for example, when you install in hot climates, what is about your temperature coefficient? what losses can you have from resistance. So we also design on this way, but also on a mechanical way. For example, the weight, the size, how can you handle the module? How can you install the module? The transport and unpacking of the module, because we know that transporting PV modules also may affect, and we can receive modules with problems with micro cracks, to be more specific. And it's important to make sure we have a robust packaging and that we can transport the modules on a safe way. I would add here one topic that is very hot in our days, that is also the cost of the transport. So not only to make sure that it's a safe transport, but the number of units that you can transport is more and more important, because the pricing is going up and up regarding the transport of the modules. Sorry. So this is our new solution. Here is where we present the main parameters of our N-type TOPCon. So we are starting with the output power of 570 watts. In our IMO5 series, when we launched it last year, we were on the 540 watts with 21.5% efficiency, and we now gave a step forward to 22.3%. Okay, so this is already one difference, and a very interesting one, coming back to the point of the efficiency, but also the other parameters. For example, we know that the VOC, or the open circuit voltage, is the parameter that allows us to calculate the number of modules that we can install per string. And we had 49 point something in our IMO5 series, and now we have 51.6, meaning that this may, and this needs to be calculated, but this may allow us to install one less module per string when comparing to them to our other mainstream, the IMO5. But in fact, we will have more output power on the string, because also the module has more power per unit than in our IMO5 family. Other concern, and coming to the compatibility with the system, is the current. So LONGi considered, and we did already this for IMO5, that we should be below the 15 amperes to make sure that our final client has all the options available on the market for string inverters. So we still have the 13 amperes for our N-type module, even if we increased a little bit our VOC. Other parameter that gets better or improves if we compare it to the IMO5 series is the temperature coefficient. If we want to read this, we are saying that for each degree we increase from the nominal temperature of operation, we will lose 0.31%. So as much close to zero, the better. And the P-type has 0.35, and we came now to 0.31. So this is also an improvement, and makes us think on applications for hotter climates, like desert conditions and so on. Other parameter, and let me at least comment that from LONGi we see a very interesting growing on the demand for bifacial modules, and we are here comparing the bifaciality of our mainstream IMO5 with the new one, N-type, and we grow 10% on the bifacial factor. So on the IMO5 we have 70 plus minus 5, and on the N-type we have 80 plus minus 5%. To make this a little bit more clear, we ran a program in China where we compared our IMO5 mainstream with our IMO-N in exact installation conditions, so the same albedo, the same distance, the same height, everything was the same, and we calculate what generation we could achieve from one and from the other, and we understand that if we speak about energy yield, we can increase by 1.7%. And this is a quite interesting result if you consider to use bifacial in future projects. Speaking now of the warranty, and this is also a big topic because if we consider the financial modules, we know that the degradations, the efficiencies have direct impact when we ask for financing and we want to develop our financing model. And the news with this new N-type is that we were offering that the module will not decrease more than 2% on the first year. And now this value on the N-type solution is reduced to half of it. So our warranty now is that the modules will not lose more than 1% on the first year. For the rest of the years, we also have a difference. So we came from 0.45% per year on our bifacial IMO 5 to 0.4% per year on our type N. And the 30 years for performance warranty, like we were already giving for the bifacial on the IMO 5 series. Okay. Just one small note, because I'm asked a lot of times about this. All the products in LONGi has 12 years product warranty. So this graphic, we are presenting our power or performance warranty, but also the modules have 12 years product warranty. In what we really want to understand is what results can we achieve if we use one solution or we use the other solution. So the next slides, I will try to show you some of our tests, some of our programs where we compared some parameters and got the result. For example, we understood that because of a lower temperature coefficient or more close to zero, we can have a difference of around 1% on the energy yield if the modules need to be working on hotter conditions. One topic that is quite interesting, because we don't have optimal climatic conditions, or depending on where you are installing, you can have, for example, the beginning of the day, the end of the day, where you also want to produce as much as possible. But even during a normal day production, you can have clouds or other topics that can reduce the irradiance that hits the modules. And it's very interesting to understand how the modules behave on these conditions. So not with 1000 or 1200 watt per square meter, but when we go below 700 watts, mainly, what is the behavior of our module? And we understand by our programs that the type N behaves better with low irradiance. Okay, and you can see on the graphic the difference that we achieved by using one mainstream or the other. We also know that the PV comes from the photoelectric effect, and the LID, the light-induced degradation, is something that we need to accept, that is inherent to the photoelectric effect. But the idea is to reduce the LID as much as possible. And for the type N, we have very good news, because we can almost say that the LID in this case is zero. I would say we don't live in a perfect world. There is no zero risk. There is no zero whatever. But in this case, the LID is 0 point something. So that's why we wrote it approaching zero. And this is quite good and interesting parameter also when you compare the solutions P-type or N-type. But in the end, I normally say that the clients do not buy modules to me, they buy power. No one asks me to sell 70,000 modules. They ask me 30 watts, the megawatts, they ask me 100 megawatts. And in the end, what the client and the investor is worried is about the generation. So let's look to the energy yield. Let's compare. You have on the dark gray our other mainstream, so the P-type solution. On the light gray, the N-type solution, and the red line show us what is the average gain that we can get by using the new technology comparing with the former mainstream. So you can see here that we are speaking about 3% on the energy yield. This was not only conducted by LONGi, this was conducted with international entities that we all know quite well, so that we also have their feedback and their know-how to allow us to generate this result. The PID is another topic. I have been around for a while in the sector. I still remember the first projects that suffered from PID. I can tell you that for example, I inspected a PV plant where, because of PID, they were losing 80-something% of the performance of the plant. So this was a high concern some years ago. The sector was able to control the PID effect on the P-type modules. But on the P-type modules, the PID is mainly generated by ions migration. So the positive charge that you may have on your module, like for example, the sodium positive charge on the glass, the barriers like the encapsulants, are materials that are very sensitive to the PID. So as much we control the quality of these materials, the cell, the encapsulants, the glass, the better resistance we have to PID. On the N-type, this is not the case. So we don't have PID by ions migration, but by electronic polarization. And I leave you here a result of a study done by Tuve Island together with us, where we can show that on the N-type, the PID is not as in the P-type, meaning that we can control much better, and this topic will not be a topic for the N-type series. Mechanical load. I mentioned that this is one of the topics that we are looking more carefully because the modules growth. We have installations in all type of conditions, in very high altitudes, strong winds, other type of loads. And we did conduct tests to understand how the behavior of the N-type series is comparing to the P-type on the mechanical load size. So there is one difference, is that these HPC cells do not require backside laser grooving. And because this is not necessary, we have the result by using 5,400 Pascal, the so-called heavy snow test. And you can see that the results of the mechanical stress to the module and to the cells is much better on the N-type series. Okay. But in the end, we are thinking about investments, performance, results, and it's very important to understand from the CAPEX, from the investment, from the BOS point of view, what are we speaking about? So I leave you here an example that we conducted also in our headquarters. And what we did was we installed 100 megawatts with our P-type 545 watts. And we have this installation. And then we try to understand if we want the same 100 megawatts with our N-type 565 watts, what would be the size of the park? And you can see that you have a sector less that you need to install to achieve the same installed power. Maybe in a more clear way, if we install the same number of modules that we did for the 545 P-type solution, we would increase the installed power on the park by almost 4 megawatts. Okay? Of course, that this has a direct impact on the CAPEX and the BOS. As a kind of summary, from everything that I showed up to now, we can conclude that the energy yield, that is the most important and interesting topic because it's our generation, is what we achieve from our investment, can be increased up to 3%, can also decrease the cost of BOS and O&M, operation and maintenance. And this does not mean that to achieve these improvements, we need to have lower quality or cheaper modules. On the opposite, I showed to you that we have the LID well controlled, the PID, the mechanical load, and so on. So we are still offering highly reliable products, but improving our outcome and also our investment. Right now, the portfolio that we have at LONGi, and I think it's very important to pass this idea, is that we are not replacing the Hi-MON solution to replace the Hi-MO5. No, they both will keep on being mainstreams, and that's why we say that we have three families, the Hi-MO4. The difference is that Hi-MO4, we still have 166 millimeter cells. So it's a smaller module. It's very used for commercial, industrial, even domestic installations. But I can tell you that some of our clients still use it for utility. But our major mainstreams for utility would be then the Hi-MO5 with the P-type technology and the Hi-MON with the N-type technology. Regarding the design, dimensions, and so on, is exactly the same as I mentioned before. Finally, and this is my final slide, this is the kind of roadmap as we came in the last years to the HPC cell technology. So the sector is quite dynamic. I understand that many times is even hard for some of the players to keep up the rhythm of the sector, because almost every year we have new launches, we have new solutions, we have new designs, and the sector needs to be very active and dynamic to be able to keep up with this. And in 5 years, for example, coming from the PERC technology to the HPC is quite impressive, but this is the reality, and this will be also the way the things will happen in the future. So thank you so much. I hope you enjoyed the presentation, and of course, like Liam said, open to any questions you may have. Thank you so much.
Excellent. Well, thank you very much, Vitor. That was obviously a really quite interesting presentation to go over the launch of the Hi-MON. As Vitor says, we're more than welcome to take a couple of questions now. I've kind of gathered a few from the questions that we've had so far. There's been quite a lot of questions, Vitor, around product availability and the roadmap. Do you have any information of when the Hi-MON will be available and when it will be, or any differences between availability in certain markets?
Okay. We are planning to start the production in the end of Q4 this year. So it means November, December, we should start production. So to be available, our estimation is Q1 of 2022.
And is that going to be globally, or will different markets have
globally.
Fantastic. And then just taking you back to the product roadmap, I guess, just a little bit. Obviously, this is a very much a TOPCon product, and there are other N-type technologies available that are being investigated by the sector at large. Are heterojunction modules on LONGi's radar, or is there anything else you can share on that kind of product roadmap?
It is, of course. As one of the manufacturers that invest more on R&D, of course, we are looking to all possible solutions and technologies. I would say that the step forward to the N-type TOPCon is a natural move. Today, if you compare the cost to achieve heterojunction and achieve the same efficiency as in Type N TOPCon, it is a little bit more expensive on the heterojunction. So it does not mean that we are not looking to it, that we are not investigating, but prior to that step, this was a natural step from LONGi, coming from all the evolution we had on the efficiency of the cells and so on. This is the natural step, but yes, we are looking to other possible solutions. And I mentioned that the sector is quite dynamic. Liam, last year we presented the 182 millimeters, and this year we are presenting the N-type. So probably next year we will have a new opportunity.
Looking very much forward to hosting that particular webinar then. A couple more questions. Like I say, we've got a few minutes to go over, so if you do have a couple of questions, then do get them into us. a couple of questions here, Vitor. Are there any differences in the expected product lifetime of N-type products over P-type, or is it broadly the same?
No, it's exactly the same. If you look to the warranty chart I showed, and maybe we can level that by the warranty that we offer. We are offering the same 30 years as in our bifacial Hi-MON 5 P-type.
Fantastic. And then another question here: how is the temperature coefficient? Obviously, this is part of one of the big kind of positives around the development of N-type products. How has the temperature coefficient evolved compared to previous generations of modules?
For example, you showed, I don't know if I can still, yeah, I can. Yeah. For example, to answer directly to that question, I think that the best way is that if you have here this comparison, Liam, sure. Because this is exactly comparing what kind of performance loss you get with one and the other coefficient. And if you see on our Hi-MON at 85 degrees, we are 81.4 comparing to the 79 on the P-type. So I think this is the most clear answer that I can give with real testing.
Excellent, excellent. Just cycling through a couple of other questions here. Could you perhaps give a bit more detail, a bit more explanation around the HPC cell technology, the benefits of it, and what it really means to the performance of the module?
We see here on the N-type TOPCon that we have an efficiency growing, that we have other positive improvements like the LID, like this one, the temperature coefficient. When we speak about heterojunction, we are speaking the same regarding the efficiency, so a step forward if you compare to the standard P-type technology that we know and that we all know. Let's say that the heterojunctions is trying to get the best out of two worlds, the thin film experience and the crystalline experience. And we know that even if the efficiency on thin film is quite low comparing to the crystalline, they still have advantages. For example, if you cannot use the correct inclination or orientations, the thin film can work better, the diffuse light. If you are operating in hotter climates, you also have the thin film that works better because it has lower temperature coefficients than the normal crystalline. So I would say that the heterojunction will have the same improvements as the ones I showed today. The topic here is that the technology is still a little bit more expensive than the N-type TOPCon, but it is also a step forward in efficiency, in temperature coefficients, in degradations.
Excellent. And I guess lastly, just to finish off, if we can, there's been a couple of questions around the degradation of the panels. Could you, and I know there's obviously been quite a lot of detail in the presentation around the kind of PID-free nature of the of N-type modules. Could you perhaps give a bit more detail around the prevalence or the impact of light elevated temperature induced degradation?
Okay, in this case, first of all, and I think this is a very interesting topic, that is the LID. We almost have no LID. And light elevated temperatures degradation is totally associated to the PERC technology. So in this case, we are very comfortable because we are not expecting to have the LID effect on this type of models.
Excellent, excellent. Well, unfortunately, I think that's all we have time for this afternoon. We've kind of come a little bit over, so I'm quite conscious of allowing people to get back on with their busy schedules. If we haven't got around to asking your questions so far, then we will endeavour to answer them privately. So we'll leave the presentation open for a bit longer. So if you do have questions, do feel free to get them into us. Once again, the presentation and recording will be available shortly afterwards. A huge thank you to LONGi and indeed to you, Vitor, for speaking to us today. It was a fascinating webinar and presentation. And indeed, thank you all of our attendees for taking the time out of their busy calendars to attend today. So thank you again.
Thank you so much. And in name of LONGi, thank you to PV Tech also for this opportunity. And hope to see you again soon.